Good morning, everyone. Today we are beginning a short series on logarithms, hopefully to enable you to understand where they come from and how we use them, and to give you a little help with your maths homework. So, without further ado, logarithms part 1. Let's begin. So, let's start with the basic concept of what a logarithm is. If I told you that 10 squared is equal to 100, I think you'd all agree with that. 10 squared means 10 times 10. 10 cubed is 10 times 10 times 10, which gives us 1000, and so on. 10 to the fourth is 10,000. Similarly, in any other, what we call base, 2 squared, for example, 2 times 2 equals 4. This number here, this big number, is what I'm referring to as the base. And so over here we were talking about base 10. Here we're talking about base 2. We could do base 4, 4 cubed, 4 times 4 times 4 is 4 fours are 16 times 4 is 64. So those hopefully are familiar exponents to you. The logarithm is basically the inverse of the exponent. So for example, let's take this sample here, and the question is, what is the log, and we say in base 10 in this case, of 10,000? And the answer is 4. Let me just correct that. The log in base 10 of 10,000 is equal to 4, because 4 is the power to which 10 has to be raised in order to give 10,000. So you can read the log expression in exactly that way. You can take the base from here and the log from here and the number from here, and you can join them together in this kind of spiral fashion, if you like, to write the exponential form of that same equation. 10 to the power of 4 equals 10,000. And so you can convert any logarithmic expression into its exponent form, or any exponent form into its logarithmic form. Let's look at another one of those from above. So we had that 4 cubed is equal to 64. And therefore, we can write that the log in base 4 of 64 is equal to 3. Remember again, we take the base from here, we raise it to the power of the log here to get the number here. 4 to the power of 3 is 64. So in this way you can see that the logarithm is really just the inverse of the exponent function. And there are a lot of similarities between how we deal with exponents and how we deal with logarithms. Let's take a closer look at that in the next video.